how to build or set up a condition monitoring system. After watching the video about breakdown maintenance, which is run into failure, and preventive maintenance, now I'm going to show you how to build a condition monitoring system, which is a predictive system. So first point is to invest in all types of sensors, such as vibration to the sensor name accelerometer to measure vibrations, accelerometer, sorry, to measure vibrations, okay, dynamometer to measure force, acoustic emission to measure sound, thermocouple to measure temperature, okay, usually here just I'm going to go on a new line. Okay, so single. Okay, so concerning the vibration, it's usually Vx, Vy, and Vz in 3 direction. Concerning the force, it's Fx, Fy, and Fz, and moment. Okay, concerning the acoustic emission, to measure the sound, a thermocouple to measure the temperature, as well as, okay, so this would be the first step, is to invest in all types of sensor. As the one existing, sorry, I'm a little bit slow, so we have it here, single. Okay, so this is the first step. The next step would be to find the best spot on the machine to mount the sensors, known as optimal sensor location, usually by considering several locations, and acquire the data from all locations and consider the one that will give higher magnitude, okay, higher reading. So we find the optimal location of the sensor by the suitable, okay, equipment as acoustic emission, AE coupler, and amplifier for other sensor that will, okay, increase and boost the magnitude of the sensory data. Okay, invest or code a software to be used to acquire the data, to acquire the sensory data, taking into consideration 2 parameters: the sampling rate and the number of samples. For example, if you want the reading to be done over a period of 30 seconds, okay, which is enough time to machine a surface, and the sampling rate is 30 kilohertz, okay. 30 kilohertz, usually this value would be given sensor characteristics. Okay, 30 kilohertz is equal to 30,000 samples per seconds times. Okay, so over a period of 30 seconds, okay, you would end up with 900,000 samples. Okay, all those sensory input data are considered to be input. If, for example, we want to use a predictive system to measure cutting tool wear هو تآكل السن. So the cutting blade of the tool, it won't be sharp as it's supposed to be, and if it's not sharp, so we have to stop machining, we have to replace it. But we don't want to replace it every now and then. We don't want to stop the machine to replace it. We have to carry on, and reading from the sensory input, we should get the right information. Okay, we should get the right information before we stop the machine. Okay, so I'll give you another example. If you're driving a car and the fuel indicator in the car, you don't want to stop at the petrol station to fill up the car with fuel. So what you have to do instead, which is like more clever, so the system, the fuel indicator in the car, which is predictive system, it gives you the right information, and it tells you in a way when you have to stop and how much time left before you stop. Okay, to fill up the car with fuel. Okay, and we have to do the same here. Like, we want to correlate the input to get the information from the input, from the sensor. It will tell us when it's the right time to stop and change the cutting tool. Okay, so the next step would be the step to indicate display the sensory data indicators. Okay, after filtering the data. Filtering is used to get rid of the unnecessary noise. Okay, existing in the sensory raw data. 3 types of filters might be used: bandwidth filter, low pass filter, and high pass filter. Okay, low pass filter, it removed high frequency data. Okay, band pass filter removed low and high frequency data, and here it keeps the one in the middle. High pass filter, okay, removes okay, low frequency data. It removes low frequency data. Alright, so this has been said. We need to convert the data from time domain into frequency domain. Difference between time domain and frequency domain is the following. Time domain is just like you start recording, like for example your voice, and over a 30 second. So when you open it, just like a random data, However, frequency domain is similar to the radio. Like if you're driving in a car and you put the radio on, so this station has this specific frequency, and another station has a specific frequency. So there are several frequencies on the range. So when you do filtering, you know which one to keep, which one to get rid of. So in order to use filtering, in order to filter the data, you must change it to frequency domain as fast Fourier transform. Okay. So the next step is to apply signal processing methods. Okay, time domain and frequency domain methods. Okay, and once all this been done, we have to use neural networks to correlate input data to the output data. In our case, input data are sensory data, and the output data are the cutting tool length. Okay. Once correlation is established, using neural networks, we are ready to go. From now and on, no need to stop the machining every now and then. No need to dismantle the tool. Dismantle يفكها. Okay, take it apart. Dismantle the cutting tool. Put it under the microscope to measure the cutting tool length. Okay, and that is it. So this is enough. Those steps are basically the one needed to construct a condition monitoring system. I will post this on Moodle, or just watch the video is enough, and you have to memorize them by heart. So those are the steps needed to build a condition monitoring system.